So in this series, we're asked, does it converge or does it diverge? We don't need to estimate its sums, none of that error crap that we've learned. But we are asked, does it converge or diverge? Now you have to ask yourselves a series of questions. Okay, can I do a divergence test easily, or am I going to have to go through headaches? Well, for this one, it actually turns out that you could do a divergence test. You'd say that this is actually this quantity times e to the n. Okay, and you find it to be 1 over infinity. 1 over infinity is 0. So it's indeterminate by the divergence test. So you hit a dead end there. You might do the integral test, and you're like, how do I take an integral of that? Well, don't even try, because that's going to be a very, very difficult integral to do. So don't give yourself the headache if you don't have to. There's other fish in the sea, so to speak. You know, maybe you got broke up with and you got in that line. I apologize. Do not mean to bring out any trauma. But there's other fish in the sea, meaning there's other tests, okay? So you can't do an integral test. You did the divergence test, it's indeterminate. You might try another test. What would those tests be? Well, you have the convergence test for one that you could try, or sorry, not the convergence test, the comparison test. All right, you compare one series to another, and you can make some conclusions about that. That's what we'll try here. This actually turns out you can, because when you look at it, you should try and find a piece, a little piece to the puzzle. What series could I make out of this one that shares something that's a little bit different? Okay, that doesn't have all the junk on it. Well, the junky bits to me looks like e to the negative n and then the plus 2n. Those are kind of constant values. We'll see why e to the n isn't important, because it is growing the function, but this one here, it's just a constant. So I'm going to realize there's another series that I do know the convergence or divergence of that follows p series, which is 1 over n squared, which is basically like getting rid of this and e to the negative n. Now, think about it. 1 over n squared, that is going to be the p series. We know that if the exponent is greater than 1, it's going to converge, because what's going to happen is you're going to plug in values going to infinity, and that's going to grow the denominator into a very, 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 very high value, which is going to make it approach 0. No, remember, if it's equal to 1 or less than 1, it's going to do the opposite of that, right? So hopefully that idea makes sense. But yeah, let's get into the actual comparison now. To determine if this is greater than or less than this, we need to determine what e to the negative n is doing and the plus n to n is doing. I want you to realize for the plus 2n, we're adding a constant value. We're starting at 3 and we're going 4, 5, 6, 7. We are growing the denominator for every n value compared to this one. So if this is growing the denominator, what does that do to the overall value? Think about what happens with 1 over 1 to 1 over 2 to 1 over 3 to 1 over 4, right? As we increase the value of our denominator with a constant numerator, which in this case would be 1 really, because this would be this quantity times e to the n, right? It's making the value less, right? This is like 0.5, this is 0.3 repeating, this is 0.25, right? The value of the fraction gets less and less and less when you put it in decimal form. That's what's happening here. That means that the denominator here is greater than the denominator here. So, or the value that you get is greater here than here. If it was just this. Now, we need to determine, is this a more complex case, or is e to the negative n, is that going to decrease or increase the value of the fraction or the series here? So e to the negative n is like writing 1 over e to the n. E is roughly, I forget, what is e again? It's like either 3 or 2 point something. 2.718. It's a constant value. It's not like some magical little number that decides to change up on you, right? So this is like this value to the n, and if I make it 2, it's this times itself. If I put it to 3, it's this times itself 3 times. If it put in 4, it's going to go this times this times this times this, and you're going to get a large number. Basically, it's doing the same effect as this. It's growing for every time we plug in a new n, and therefore it's growing the value of the denominator. And if we grow the value of the denominator, we just said that that's going to decrease the overall value. So basically these two have the same effect, right? The e to the negative n and the plus 2n. It's going to decrease the value of the partial sum. So that means that this is greater. Okay, hopefully that idea makes sense. Just showing that relationship. We said that this was convergent. So this means that it actually tells us something. Let's make a graph to kind of show this here. So we have a little graph. Imagine I plotted these as functions. Now imagine this is, I'm plotting this one as blue. Okay, this one's greater than this one. So let's just say it's doing some weird behavior and it's like woo, 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 and it converges down to a singular value. Always decreasing, let's just say. Okay, now let's say this one converges. Okay, this one's converging as well because it is less than this one. Basically how I show this is I say, okay, it's never going to be able to escape the bounds of this function here, so it's always moving down. Therefore, it's also converging. If you look at it kind of like functions, every partial sum is less than this one, and if this is converging, well, it's going to push it or squeeze it down, and it will also be convergent. So what we can say here for our answer is because our sister series is greater than our parent series, because this is true, which is just this inequality flipped around, basically rotated 180. Because that is true, and we know that our P series is convergent, because this series is convergent, well, or than our parent series is also convergent. Okay, so just think about the process we did. We said, okay, we could maybe do a divergence test. It's not just when we can find the sum of indeterminate divergence or convergence. We can't do an integral test, but we can do a comparison test. And if the comparison test didn't work, we'd then do a limit comparison test, okay? But we found here that the comparison test works, and because this function is greater than this one, or this series is greater than this one, and this one's convergent, this one also must be convergent. That's how you solve these kind of problems. I hope you guys enjoyed. If you did, please drop a like, comment, and subscribe. I would love to hear your feedback on these videos, and have a wonderful day.